Grüezi YouTubers, here is the guy with the Swiss accent again. AI Thinker are the manufacturers of our beloved ESP12 modules. These modules gave us the very low-cost Wi-Fi connectivity. This is why they are very successful with their ESP8266 modules. Now the same company tries to do the trick again. They provide a small and cheap machine-to-machine communication module. It uses the same worldwide GSM network as our mobile phones. Therefore, it frees our devices from our local area network. This video gives you a first impression about this new module. At the end, we will be able to post our first data to the cloud. By the way, the name of the module is A6. The module itself is very small, only 23 × 17 mm. For size comparison, the module itself is smaller than a normal Swiss stamp. This module, including some additional components like a SIM card holder and an antenna connector, is sold on AliExpress for just $4 including shipping. It even includes a small antenna. But what is the difference between this module and the ESP8266? First, it uses a different network. The ESP8266 uses Wi-Fi. This is no problem if we are at home, because we have a Wi-Fi and know the credentials of our access point. As soon as we leave home, the problem starts. Sometimes the coverage of our Wi-Fi does even not reach the last part of our garden. And even if we are in the range of a Wi-Fi, we might not know its credentials, or the connection to it is not simple. This is where the A6 module jumps in. It uses the GSM network. Because this network is used by mobile phones, it's available nearly everywhere on our planet. Probably the only area it is not available is in my lab in the cellar of our house. This is why I had to mount my antenna high up. The buzzword used for this kind of communication is machine-to-machine or M2M. You already find many references to this topic on Google. I enclose some useful links in the comment. Another important difference is that for the moment we cannot program the internal processor as we can do with the ESP8266. The module is more like the first ESP01 modules, which contained a firmware providing some AT commands. So the A6 modules have to be used together with a microprocessor like the Arduino. A disadvantage of the GSM network is that we have to use a SIM card to access it. This adds some cost to the equation. But since we only want to transfer a very small amount of data, we can live with the cheapest prepaid offer. In Switzerland, I even found an offer which includes 10 MB per month free of charge. For M2M, 10 MB is a lot if we consider that the post to data.sparkfun.com produces less than 1 kilobyte of data traffic. We can therefore send more than 10,000 messages per month with the 10 MB mentioned before. But let's now start with the work. First, we have to prepare our SIM card. Make sure that you disable the PIN code if you want to work with my sketch provided on GitHub. Removing the PIN code can be done by inserting the newly purchased SIM card into a mobile phone. I recommend to check also if the data connection works by connecting to google.com on your mobile with your new SIM card inserted. After this test, you can insert the card into your A6 module. For my first tests, I purchased an evaluation board together with an A6 module. This board has buttons and a display. It also has a USB connector which can be used to do our first test. However, I did not figure out how the keys and the display works. The only thing I used it for is a nice stand and an alternative for a breadboard to do my first tests without an Arduino. To do so, you plug in the A6 module to the evaluation board, set the switches to the right position, connect the USB connector to your PC and start PuTTY. You find the right serial connection in the device manager. The initial speed of the A6 is 115-200 baud. Now we can start our communication. If we send AT to the module, it answers with OK. This shows that the communication works. If we press AT plus CSQ, we get an answer like plus CSQ 0,0 or plus CSQ 7,99. The first shows us that we have no signal. The second shows that we are connected to the GSM network. After a while, the module sends some other data which you can ignore for the moment. Because the A6 module has the same functionality like a cheap mobile phone, you can now place your first phone call. Of course, only if you purchased a SIM card allowing phone calls. Just key in ATD and the number you want to call. And it works. After these tests, we want, of course, to connect it to an Arduino and do some real stuff. As usual for such project, I use an Arduino Mega because it has 3 serial connections. I will use serial for debugging and serial 1 to connect to the A6 module. To do this, we either have to connect the wires directly to the A6 module, or we keep the module on the evaluation board and connect the Mega to this board. Let's have a closer look at the evaluation board. It has its own MCU, a well-known CH340 USB to serial adapter, a keyboard, and a display. In addition, there is a LED, the headphones connector, a relay, and a buzzer. In the middle of the board we find 6 dip switches. They are used to choose how we want to connect the different parts of the board. For a first test, I wanted to use the keyboard and the display. To do that, I had to connect the MCU to the A6 board. So I had to set switch 5 and 6 to on. If you want to connect the MCU also to the USB connector, you have to switch 1 and 3 also on. Unfortunately, both possibilities were not usable for me. First, there is no description available, and second, the reaction time of the keyboard is unpredictable and the USB connection says always that the module wants to connect to the AI cloud. But obviously is not successful. Maybe someone else is more successful exploring these possibilities than myself. The evaluation board has no serial connector to the outside. The Arduino Mega, on the other hand, needs a serial connection. So we have to use our soldering iron and connect the respective wires ourselves. We connect 2-pond wires directly to ground, RXD and TXD. For your information, here you see the respective pins. In addition, we also connect a wire to the reset pin of the A6 module. My test showed that it is always good to reset the module before you start with your commands. The reset pin has a negative logic and draws about 70 mA if you pull it to ground. Because an Arduino cannot provide this current, you have to use an N-channel MOSFET to do the trick. At the end, you should have your board wired like this, drawing to your Mega. Now we can start loading the first sketch to the Arduino. You find a link to GitHub in the comments below. The first sketch is called A6 Debug. All it does is take your serial input and send it to the A6 board and vice versa. But first we have to power the evaluation board. 2 possibilities exist. First, we can power it via the USB connector. Please be aware that during sending, the module draws a lot of current. So connect it to a power bank or to a strong USB power supply. Or you connect 5 volts to the power plug. There is a 3.3 volt regulator on the evaluation board and also one on the A6 module. So maybe you can also power it with more than 5 volts. But I did not find good information. I also do not know if the pins of the A6 are officially 5V tolerant. So far, the only thing I can say is that my module survived. If we set now the serial monitor of the Arduino IDE to 115/200, we can enter AT and should get OK. If this is OK, you can continue with loading my example sketch. It can call a number, send an SMS to another mobile and post the value of pin A0 to data.sparkfun.com. Let's test first the call. I enter the number of my office telephone into the sketch, and if I key the command B for voice call, it calls my phone. All OK. Now we send an SMS to my mobile. Also this works after entering the command T for text message. Now we want to do some real machine-to-machine communication. We use the example code of video number 58 to post a value to sparkfun.com. To get a real value, I connect the A0 pin to the battery voltage, including a small voltage divider. We watch now how the A6 module connects to the GSM network, establishes a TCP/IP connection via the GPRS service, checks its IP address, connects to port 80 of data.sparkfun.com, and sends the required GET request to post the battery reading to the cloud service. If everything works, SparkFun replies with a 200 message. Finally, we can check if the value was posted. This setup works now globally. The only prerequisite is that you use a SIM card which supports the network in the particular country. As usual, we have to come now to the negative side. A few years ago, the first GSM modules for Arduino came on a shield and used the SIM900 chip. This chip uses its own AT command set, and clever people wrote a GSM library for that shield. Using this library made things easy for the users. Later came modules with the SIM800 chips, and their libraries were adjusted. Unfortunately, the AT commands are not completely standardized, and the GSM modules do not behave always as they should. In short, all available libraries did not work for the new A6 module. Also, the information from AI Thinker is not completely accurate and only in machine-translated English, which did not always help. In addition, it was the first time I used GSM protocols. But finally, I got it running in 2 different countries and with 2 different networks. How to establish the connection to SparkFun and post the values will be topic of one of the next episodes. If you subscribe, you will be automatically alerted if it's ready. I hope this episode was useful or at least interesting for you. Bye!